Now, in the earlier lecture, we have already designed the C purlins to support the, we can say, footover bridge. So in this lecture, what we shall do is that we can model the, we can say, purlins also on the top of this particular structural street arrangement. And what we can do is that we can go to define section properties and frame section, and the purlin that is safe as per the X Factor design software is EC15010. That is C purlin of 150 mm depth and 1 mm thickness. So we can go to the add new property and we can click on C channel. Please note that we won't be designing these C purlins in the ETABS software. We have to design the code form section in the specialized code form design software or with the help of the Excel files only. So what we should do is that we are just modeling it to keep the self weight and the structural like connection that shall be there at the time of, we can say, the fabrication or erection. So we can keep it as 150 by 50. Flange thickness we can keep it as 1, and web thickness also we can keep it as 1. And material we can keep it like this only, that is 11 to 17. And as I said that we won't be designing it, so it doesn't matter much. So what we can do is that we can go to draw beam, column, and brace objects. In here, under the frame section property, we can select the C15010, and the moment releases has to be pinned only. So we can like model the beam from this point to this point. And what we can do is that we can select the beam again, and we can replicate these beams along the y-axis. So we can select dy as minus 0.5, and number we can keep it as 6, and then we can just like keep the cursor over here, and we can see here that we have added 2 extra purlins. We can just simply select them and delete them from with the help of delete option on your keyboard. We can go to Control W also, and in here we can go to the object assignment. In here we can click the sections and end releases. That shall be very helpful when we are designing or modeling the system. So we can select all of these beams here again, and we can click on Control R, Control option and R option on a keyboard. Instead of, we can say, dy, we can enter dx here as 3, and number also we can select here as 2. We can just like move our cursor over the apply option. I think there is a difference in the dimension. We can go to the draw and dimension line. So in here, okay, so the distance was approximately 2 meters. So instead of the 3, we do need to select here as 2 meters. We can left click on apply, and now the secondary C purlins are modeled correctly. So this part is now done, and after that what we can do is that we can go to the define section properties and slab sections. In here again we can either click on the plank property, and we can assign it as a membrane. We can keep the thickness in 1 mm just to ensure that we do have a system where we can transfer the loads correctly on the, we can say, C purlins. Or what we can do is that we can like apply the universally distributed load also on all of these C purlins. Both the options are correct, and we can just rotate the model with the help of this option here, and we do need to ensure that there is no SS supports here. So we can like draw a rectangle here and go to the assign, joint, and restraints, and we can just click on none, apply, and okay. So here we can see that now we have taken these 2 supports here, and there are no SS supports in between. The members are modeled, the C purlins are modeled. The secondary frame to transfer the load of the C purlins to the main structural arrangement is also modeled. So now what we should do is that we should model the remaining footover bridge. But before that, what we need to do here is that to reduce the modeling time and reduce the length of the lecture also, we shall instead of 30 meter, we shall model the 20 meter span footover bridge. That is the distance from one point to the last point shall be approximately 20 meters. So what we can do is that we can go to edit, stories, and grid systems here. We can left click on modify and show story data. So in here, instead of 2, we can enter here as 1.5. So the elevation shall be approximately 2 meters here, and we can left click on refresh view, okay, and then again okay. So if we check the height of the photo image now here, so here we can see that at this particular point, you do need to check this particular location for the coordinate. So if we point our cursor to this particular point, our z is 0.5, and in here the z is approximately 2 meters. So the distance height from this point to this point is approximately 1.5 meter. So that is in line with our requirement that for 20-meter span, we can go for as high as 1.5 meter height also. Now, if we want to model the 20-meter span, so in that 20-meter span, the 10 meters span should be having bracing in this particular direction, and the rest shall be having in the other direction. So we can rotate the model from this particular option. We can select all of these like beams and purlins here. We can go to the control and R option here. And in here we can select dx here as 4 meters. And number we can select here as 1 only as of now. We can left click on apply. So now we have like 1, 2, 3, 4, and 5. So now we have modeled the photo pitch up to, we can say, 10 meter span. That is from this point to this point. It is approximately 10 meters. Now what we can do is that we can just simply either model the remaining photo pitch manually, or we can just select all of these the whole structural arrangement here. We can rotate the model like this. Yeah. So we can draw a rectangle from bottom to top. And in here we can go to the edit. And in here we can select the replicate. And under the replicate option, we can select mirror option here. Like instead of selecting up from this point to this point, we do need to select the horizontal line here. That is from this point to this point. So we can left click on apply here. And here we can see that now our complete 20-meter span photo bridge has been modeled. So if we want to select a dimension here, that is 2, 4, 6 meters, 8 meter, 10, 12, 14, 16, 18, and 20 meters. So now we have modeled the complete 20-meter span of photo bridge, and we can go to the control W option, and we can left click on extrude frames option. We can switch off the sections and end release assignment, left click on apply. So this is the photo bridge that has been modeled in our case, and here you can see that how the half of the spans are having the diagonal members in this particular orientation and the remaining in this particular orientation, so that all of these members are in tension only. And we do have the flooring also with the C purlins that we had assumed in our earlier assumption. So now we have modeled the complete photo bridge from one point to another. So that is the basic criteria. The similar exercise can be done if you want to model the span of 30 meters, but that shall take we can say a lot of time in load application and all. So that is why this is the correct thing, that whatever bridge that we are having, we can just simply have a mirror image on the other right hand side.